Hello students, welcome to this class. Today I will be discussing multiple choice questions on the chapter some basic concepts of chemistry, that is from first year PUC. It mainly involves the stoichiometry, mole concept, law of chemical combinations and chemical arithmetic. So let's consider the first question. A wrong statement about homogeneous mixture is: there is a visible boundary between the components. See, visible boundary will be present only if it is a heterogeneous mixture. Like you may imagine the mixture of, say, petrol and water. So the lighter one will be floating. So you can see there will be a different color. Even if it is colorless, you can see some difference in the absorption of light. You can identify the interface, the junction between the two liquids. Or if it is a mixture of a solid that is insoluble in a liquid, you can see the particles. Even with an ultra microscope, if you can see the boundary, then we say it is a heterogeneous mixture. Like milk appears to be homogeneous, but actually when you look into it using an ultra microscope, you can see fat globules dispersed in water. So in a homogeneous picture, there will be no visible boundary. Therefore, first statement is wrong. It has uniform composition. That is correct. Say if you have sugar dissolved in water, a sugar solution. So whatever will be the density in any part of the solution, or if it is a colored solution, the color. If it is the taste, the refractive index, everything will be same in every part of the solution. So the second statement is correct. Cannot be separated into components by filtration or decantation. Yes, homogeneous mixtures cannot be separated by decantation. If you have salt dissolved in water or sugar dissolved in water, so if you conduct an ordinary filtration using an ordinary filter paper, so you cannot separate. It cannot be a mixture of two or more solids. Yes, homogeneous mixture cannot be a mixture of two or more solids. Say if you mix salt and sugar, you can easily identify the sugar crystal and also the crystal of salt, because they will be having different refractive indexes. Therefore, shining will be different, crystal sizes will be different. You'll be able to identify it very easily. Therefore, the statement 2, the B, C, and D are correct. So, wrong statement is A. Therefore, answer for this question will be A. Next question, identify the correct statement or statements. So, there may be different statements that may be correct. Then you will be given other options also. Elements are made up of identical atoms. That is true. Say when you say hydrogen, it is made up of identical atoms having one proton, one electron. If you say sodium metal, all sodium atoms are identical in their mass, in their composition. Compounds are made up of identical atoms. It is wrong. Compounds are made up of different atoms. For example, when you say H2O or when you say CS2, they are made up of different elements. So when there are different elements, there will be different atoms. Elements and compounds have identical properties. Again, that is a wrong statement, because properties of H2 and properties of O2 are completely different from the properties of H2O. See, H2 is a combustible gas, oxygen is a supporter of combustion, whereas water is used to extinguish the fire. So it is in liquid state, whereas H2 and O2 are gases. So there will be different properties. Therefore, C is wrong. Atoms of a compound are separated by physical methods. See, you cannot separate hydrogen and oxygen by physical methods like filtration or distillation or something like the chromatography. It is not possible. It has to be decomposed either by heating or by electrolytic processes. So it requires a different method. Electrochemical process or a chemical process is required. Therefore, statement D is also wrong. So only correct statement is A. Therefore, that will be the answer. Which of the following is not a fundamental or basic physical quantity? No electric current, which is given as the ampere unit, temperature with Kelvin and length with meter, or fundamental SI units. There are 7 fundamental or basic SI units, where density is a derived physical quantity. So it is mass divided by volume, therefore it is a derived physical quantity. Therefore not in the case, the answer will be B. So density is not a fundamental physical quantity. Giga corresponds to, no, it is about the prefixes and suffixes that we use. So gigameter, so like we say, so what are the value of the prefixes that we use before the unit? Say 10 to the power of minus 3 is actually millimeter, milliliter, ml. 10 to the power of minus 6 is micro. So you have to remember a few of these things. Whereas this is hecto, H, and this will be giga. 10 to the power of 9 plus 9 is giga. Similarly, you have to remember 10 to the power of minus 9 is called nano. 10 to the power of minus 12 is called pico. So you have to remember some of these things, like 10 to the power of 3 is kilo. You are very much familiar with. So ಇದರಲ್ಲಿ ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಈ ತರ ಕೇಳಬಹುದು. So answer for this question will be D. Giga is 10 to the power of plus 9. Expressing 0.0034 in scientific notation. ನೋಡಿ, scientific notation ಅಲ್ಲಿ ಬರೆಯುವಾಗ 1 digit plus decimal point should be there. So I have to shift this decimal point 1, 2, 3 places to the right side. Therefore, the value of 10 to the power will decrease. So ಇಲ್ಲಿ 10 to the power of 1 ಇದೆ ಅಂತ, okay, 10 to the power of 0 ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, it goes on decreasing, becomes 3.4 into 10 to the power of minus 3. 10 to the power of 0 is 1. ನೀವು ಇದನ್ನ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಆಗುತ್ತೆ, ರೈಟ್ಗೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ, ಲೆಫ್ಟ್ಗೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ವಿಲ್ ಬಿ 3.4 into 10 to the power of minus 3. Or you may do it by multiply and divide by 1000. ಆ ಥರನೂ ಮಾಡ್ಬೋದಾಗುತ್ತೆ. Answer for this will be C. Which of the following statement is correct? Many statements may be correct. Last digit of measurement is called uncertainty digit. Yes, it is correct. Say when you measure length of a line using a scale, say if you say 2.2 centimeter, then we say the last digit is uncertainty digit. That means an error may occur in the last digit as per the capacity of the instrument that you are using. Closeness of values measured in different trials is called accuracy. No, actually it is called precision. Say 2.2 centimeter is measured by one student, another one measured it as 2.1, another one measures it as 2.3. Then we say they are precise, they are very close to each other. 2.1, 2.2, 2.3, they are close to each other. Therefore, we say there is a precision in the trials. Closeness of a value with respect to the actual value is called precision. No, it is not actually. It is called accuracy. See, it is the definition of accuracy. See, the length of the line is exactly 2.2 centimeter and somebody measures it exactly 2.2, then we say it is accurate. All digits of a number that refers to a count or certainty digits. See, this statement is correct. See, when you give a count of anything, example is given here, 12 pencils, so there will be no error. So ಇದರಲ್ಲಿ ನಾವು uncertainty ಇದೆ ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ಲ. If somebody, say cricketer scores say 100 runs in a match, then we say there is uncertainty, ಅದು 99 ಇರ್ಬೋದು, 101 ಇರ್ಬೋದು, ಎರರ್ ಇದೆ ಅಂತ ನಾವು ಹೇಳಕ್ಕಾಗಲ್ಲ. Therefore count is always a certain digit. Therefore there are two correct statements, A and D. So the answer is C. Both A and D are correct statements. That will be the answer. Which of the following is not a correct statement? Again, with respect to significant figures, leading zeros are never significant. That is correct. So if you write something as 0.0059, then these zeros are not significant. Zeros between non-zero digits are always significant. If you write a number as 101, you cannot say that 0 is negligible. Trailing zeros are significant only if a decimal point is there. See, if you write a number as 100, then it has only one significant figure. But if you write a decimal point like this, then it has three significant figures. When you write 100.0, then there are four significant figures. ನೋಡಿ ಇಲ್ಲಿ 0 ಬರ್ದಿಲ್ಲ, ಬರೀ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಹಾಕಿದ್ರೆ ಸಾಕು, ಅವಾಗ ಅದಕ್ಕೆ ಝೀರೋಸ್ಗೆ ಒಂದು ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಸಿಗುತ್ತೆ. ಸೊ ಟ್ರೈಲಿಂಗ್ zeros are significant only if the decimal point is specified. That is also correct. Statement D, trailing zeros are significant even if the decimal point is absent ಅಂತಿದೆ, ರಾಂಗ್ ಆಗುತ್ತೆ. Therefore there are two statements here, A and D. So ನಿಮಗೆ ಇನ್ನೊಂದಷ್ಟು ಆಪ್ಷನ್ಸ್ ಕೊಡ್ತಾರೆ, then you have to choose the answer. Both A and D are correct. So additional ಆಗಿ you will be given some more options. So ಇದರಲ್ಲಿ ರೂಲ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ಸ್ A ಮತ್ತೆ D ಅದು ಕರೆಕ್ಟ್ ಆಗಿದೆ. A value with 5 significant figures is. See, in the first one there is a decimal point, therefore 1, 2, 3, 4, 5. So 5 significant figures are there here in the A. In B, starting zeros are not significant, therefore there are only 2 significant figures. ಇಲ್ಲಿ decimal point, I can observe there is no decimal point here, therefore it has only 3 significant figures. Here there is a decimal point, there are 3 zeros. That means we have used an instrument that is accurate up to the 10 to the power of minus 3 unit, third decimal digit. Therefore all the digits are significant. Totally there are 6 significant figures in this. So value with 5 significant figures is E, and that will be the answer. See, if you convert that into a scientific notation also, you can understand how many significant figures will be there. ನೋಡಿ, ಏನ ನಾವು ಸೈಂಟಿಫಿಕ್ ನೋಟೇಷನ್ ಮಾಡಿದ್ರೆ 2.0190 ಬರೀಬೇಕಾಗುತ್ತೆ ಅಲ್ಲಿ, then it becomes 10 to the power of, shifting to right, 10 to the power of 3. Whereas in this case you have to write it 8.0700. You have to write all the numbers and then you have to give it. Therefore there will be, you can easily understand how many significants are there by converting that into scientific notation. Decimal point illa andre, then you can write it as 3.45 into 10 to the power of 3. You can just write like this. So there are only 3 significant figures. So converting a number into scientific notation may help you to understand how many significant figures are there. The sum of 3 numbers is given. It should be given as, see, first number has 5 significant figures, second one has 3 significant figures, and the third number has 4 significant figures. So answer, it looks like 5 significant figures, but you have to give the answer to that number which has got least number of significant figures. Least number of significant figures irodu 2.43 nalli, it has got 3 significant figures. Therefore you have to round it off. So rounding off rules use ಮಾಡಿಕೊಂಡು 3 significant figures ಇರೋ ಆನ್ಸರ್ ಕೊಡಬೇಕು. ಸಿ ಆನ್ಸರ್ ಏನಲ್ಲಿ 5 ಇದೆ, ಸೊ ಅದು ಬರಬಾರ್ದು. 3 significant figures is in B and that will be the answer. So you have to report that answer as 7.22. This has 4 significant figures, this has also got 4 significant figures, so ಅದು wrong ಆಗುತ್ತೆ. So it depends on the number which has got least number of significant figures. So it should be reported up to 3 significant figures. That should be written as 7.22. The product of two numbers 2.8003 and 1.6 should be rounded off to. See, this has got 5 significant figures and this has 2 significant figures. Again, the same rule you have to apply. You have to report the answer up to the number which has got least number of significant figures. So least number of significant figures here are the 1.6, okay? That is 2. So product should be reported. Adenaru ಬೇರೆ number ಬಂದಿದ್ರು you have to apply the rules of approximation and then report it up to 2 significant figures, and that will be the answer. Law of multiple proportions is not applicable for, see, law of definite proportions is the law of multiple proportion. Law of reciprocal proportions is not given in the NCERT text, and Gay-Lussac's law of combining volumes. Now it says the two elements combine to form different compounds. The mass of the element that combines with given mass of the other element will be a simple ratio. See, here mass of oxygen is 16, here mass of oxygen is 32. That combines with 2 grams of hydrogen, and that will be in the ratio 1:2. So that comes only when the elements that are present are same, CO, CO2. So the same elements ಇದೆ ಬೇರೆ ಬೇರೆ compounds, ಬೇರೆ ಬೇರೆ ratioದಲ್ಲಿ combine. But here you find completely different elements, H2O, CS2, even CO2 ಕೊಟ್ಟರು that will be wrong. So D does not come under the law of multiple proportions. So that will be the answer. It is not applicable ಅಂತ ಕೇಳಿದ್ದಾರೆ. Dihydrogen and dioxygen always combine in ratio 1:2 to give water. So ನಾನು ಹೇಳಿದೆ law of definite proportions ಅಂತ. So H2O you may get it by different reactions like combining hydrogen with oxygen, or you may get in the form of a byproduct during reactions like NaCl reacting with NaOH reacting with HCl to give salt and water, or you may get it as a byproduct of, say, combustion reaction. But H2O always combines, will have the same ratio of the elements, and that is known as law of definite proportions. So you may get a compound by different methods, but it will have same formula. That means the elements will combine in the same ratio. Therefore, answer will be this, D. 1 liter is not same as. See, many students go wrong while calculating the molality when unit of volume is given in different ways like cubic centimeter, liter, etc. See, 1 liter is same as 1000 cubic centimeter. 1000 cubic centimeter means what? Centimeter, centimeter, centimeter. So it will be 1000. See, centim is 10 to the power of -2 cubed multiplied by cubic meter. So that will be 10 to the power of -3 cubic meter. But ಇಲ್ಲಿ 10 to the power of 3 cubic meter ಕೊಟ್ಟಿದ್ದಾರೆ, that should be wrong. 1 cubic centimeter is same as 1 ml. Milliliter lab alla ಹೇಳ್ತಿರ್ತೀವಿ 1 cc or 1 ml. Therefore this is correct. 1 cubic decimeter is also right. 10 to the power of -3 is nothing but 10 to the power of -1 cubed cubic meter. 10 to the power of -1 andre deci. Therefore it will be deci cubic meter. So that will be cubed. Therefore 1 liter is same as A, it is same as B, it is same as C, but it is not same as D. Therefore that will be the answer for this question. 10 to the power of -3 ಅಂತ ಕೊಟ್ಟಿದ್ರೆ ಸರಿ ಆಗೋದು, +3 ಅಂತ ಕೊಟ್ಟಿರೋದ್ರಿಂದ that will be wrong conversion. How many moles of magnesium phosphate will contain 0.25 mole of oxygen atoms? See, 1 mole of Okay, molecule ಬೇಕಾದ್ರೆ ತಗೋಬಹುದು. 1 molecule of magnesium phosphate. So how many atoms of oxygen are there? 4 into 2. You can see here 8 atoms of oxygen is there. Therefore 1 mole of magnesium phosphate will have 8 mole of oxygen atoms. So oxygen atoms. Now 0.25 mole. So how many moles? X moles of magnesium phosphate will be containing 0.25 mole of oxygen atoms. So that is asked, how many moles of magnesium phosphate will be containing 0.25. ನೋಡಿ ಇದನ್ನ ಈ ತರ ಬರ್ಕೊಂಡು ಅದು ಗೊತ್ತಿಲ್ಲದೆ ಇರೋದನ್ನ x ಅಂತ ಬರ್ಕೊಳ್ಳಿ, ಅದನ್ನ ಹಾಗೆ ಫ್ರಾಕ್ಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ. Then you can solve it as per the mathematics. So ಇದನ್ನ cross multiplication ಮಾಡೋದು 0.25 divided by 8 equals x. So if you do it, it comes to 0.03. That means it is 3 into 10 to the power of minus 2, very close to that value. ಯಾವುದಿದೆ ಅದನ್ನ choose ಮಾಡ್ಕೊಳ್ಳಿ. You need not divide it completely. So very close ಆಗಿರೋ ಆನ್ಸರ್ ಯಾವುದಿದೆ ಅದನ್ನ choose ಮಾಡ್ಕೋಬಹುದು. Therefore this will be the answer. ನೋಡಿ ಇದಕ್ಕೆ ಕ್ಲೋಸ್ ಆಗಿದೆ ಆನ್ಸರ್ 3.125 to 10 to the power of minus 2. So unknown factor na x ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಇದೆಲ್ಲನೂ ಸಿಂಪಲ್ ಅರ್ಥಮೆಟಿಕ್ primary school mathematics ತರ ಆಗುತ್ತೆ. You can do it very easily. How many moles of helium occupy 22.4 liter, 0 degrees centigrade and 1 atmosphere of pressure? See, standard volume is 22.4 liter if pressure is given in 1 atmosphere. If it is pressure is given in 1 bar, ನೋಡಿ 1 bar ಅಂತ ಏನಾದರೂ ಮೆನ್ಷನ್ ಮಾಡಿದ್ರೆ ಆವಾಗ ಅದು 22.7 liters ಅಂತ ಆಗುತ್ತೆ. So it should be, and the answer should be 1. So 1 mole, exactly 1 mole of helium will occupy 22.4 liter at 0 degree centigrade and 1 atmosphere. 1 bar ಅಂತ ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾರೆ ಆವಾಗ that becomes 22.4 divided by 22.7, almost 90% of it. So ಅಲ್ಲಿ 1 bar ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಆವಾಗ 0.90 ಆನ್ಸರ್ ಬರುತ್ತೆ. See, this will be the answer if the pressure is given as 1 bar, but ಇಲ್ಲಿ 1 atmosphere pressure ಅಂತ ಕೊಟ್ಟಿರೋದ್ರಿಂದ I have to take it as 1 mole. So answer is C. 1.5 mole of O2 combines with magnesium to form MgO. What is the mass of magnesium required? So we shall write the equation Mg plus O2 gives MgO. Now balance ಮಾಡಬೇಕಾದ್ರೆ you have to write 2 here and 2 here. See, 2 mole of magnesium requires 1 mole of oxygen. But here we are given 1.5 mole of oxygen is given. For that, how many moles we shall calculate. So how many moles of magnesium? ನೋಡಿ ಮತ್ತೆ ಅದನ್ನ ಅದೇ ತರ ಫ್ರಾಕ್ಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಈಸಿ ಆಗುತ್ತೆ. 1 over 1.5. Therefore what is x? X is 2 into 1.5. 2.1.5 ಅಂದ್ರೆ 3 mole. So 3 moles of magnesium is required. 3 moles of magnesium means 3 into 24 gram. Now you convert that into grams. So how much it will be? 72. So 72 gram is the answer. See, that is the answer. So unknown factor na x ಅಂತ ಅನ್ಕೊಳ್ಳಿ, becomes a simple mathematics. The mass of 101.35 cubic centimeter of methane at STP is, okay, we shall take it as 22.71 mole of methane occupies 22,700 cubic centimeter at 1 bar pressure and 27 degrees centigrade, 270 Kelvin. So 1 mole of methane means it is 16 gram. 16 gram occupies 22,700 cc. So 113.5 cc ಎಷ್ಟು ಅಂತ. So how many grams of this? So again ನಾನು ಅವಲ್ಲೇ ಹೇಳಿದಾಗೆ you take it as 16 by x is equal to 22,700 divided by 113.5. Now you solve for x into nitrogen marconi 16 into 113.5 divided by 22,700 plus x. So now you can see the numbers that can be 2000 and agate. So x should be 8 into 10 to the power of 700. Okay, 200 times. So 8 into 10 to the power of minus 2. 8 into 10 to the power of minus 2 is 0.08 gram. So that should be the answer. So conversion of mole into gram, volume into gram. So the relationship between mole and mass and also mole and volume. Idu ಸೇರಿಸಿದೆ. So answer is 0.08 gram. A signature written with a carbon pencil weighs 1 milligram. The number of atoms present in the signature is. This question is very much familiar question. It is asked very often. So it is about the mole and the mass once again. See, 12 gram of carbon means it is 1 mole. 1 mole means it is 6.022 ಬೇಡ ಅನ್ಸುತ್ತೆ ಆನ್ಸರ್ ನೋಡಿದ್ರೆ you can see that they have avoided the second decimal digit, third decimal digit. So 1 milligram ಅಂದ್ರೆ ಎಷ್ಟು ಅಂತ. So it is how many atoms. Now again take it as x. Now you take the ratio 12 divided by 10 to the power of minus 3 equals 6.02 10 to the power of 23 divided by x. Now solve for x. X is equal to 6.02 10 to the power of 23 multiplied by 10 to the power of minus 3 divided by 12. So this becomes 10 to the power of 20. Now this is about 0.5, nearly 6 anta ankonಡ್ರೆ 12 5 is 60. So it will be 0.5 to 10 to the power of minus 3 10 to the power of 20 10 to the power of 20. Sorry, 10 to the power of 20. So answer ideally, okay, here it is there. No real answer is 0.502 10 to the power of 20, and that will be the answer. So here the idea is to convert 1 milligram into mole or into number of atoms. So this type of question may also appear again and again. A solution contains 1.2046 10 to the power of HCl molecules in 1 dm cube. Strength of the solution is. So number of moles calculate ಮಾಡಬೇಕು ನಾವು. See 6.02 10 to the power of 23 molecules of HCl ಇದ್ದಿದ್ರೆ, then we say it is 1 mole or 1 molar solution. Now it is 1.2046 10 to the power of 24 molecules. So many molecules in 1 liter. So how many moles? Moles ಗೊತ್ತಾದ್ರೆ that will be the answer. So ಇದನ್ನು ಹಾಗೆ fraction ತರ ಅನ್ಕೊಳ್ಳಿ. So x is equal to 1.2046 10 to the power of 24 divided by 6.02 10 to the power of 23. Now you can see here it is just 10 that is left, and this is almost 0.2. So it is 0.2 10 to the power of into 10. So it will be 2. So 2 moles of HCl is present in 1 liter, means it is a 2 molar solution. So number of moles 1 liter ಇರೋದ್ರಿಂದ ಮತ್ತೆ ಸಾಲ್ವ್ ಮಾಡೋದು ಬೇಕಾಗಿಲ್ಲ. So 2 moles are present in 1 liter means it is a 2 molar solution. That will be the answer. 80 gram of oxygen contains as many atoms as in. 80 gram of oxygen moles convert ಮಾಡಿ. See 16 gram oxygen atoms. See it is atoms. Dioxygen ಅಂತ ಕೊಟ್ಟಿಲ್ಲ, O2 ಅಂತ ಮಾಡ್ಕೋಬೇಡಿ. It is not dioxygen ಅಥವಾ oxygen gas ಅಂತ ಕೊಟ್ಟಿಲ್ಲ. So take it as oxygen element only. 16 gram means it is 1 mole. So 80 gram means it will be 1 over 16 times 8. So it will be 5 times. So it is 5 mole. 5 mole of which one? 5 mole of hydrogen andre 5 gram ಆಗುತ್ತೆ. I think this should be the answer. 10 andre it will be 10 gram of hydrogen be 2 mole, 80 gram of hydrogen andre it is 80 mole, so it is 80 mole. 1 gram of hydrogen andre 1 mole agutte. So don't take it as the diatomic molecule. Dioxygen anta kottilla, oxygen gas antana kottilla. So atoms anta consider ಮಾಡಿ atomic mass na substitute ಮಾಡ್ಕೋ. So answer will be 5 gram of hydrogen. An element X has the following isotopic combinations: 90% of 200 plus 0.088% of, okay, it is 199 plus 2% andre 0.02 to 2 naught. Now we have to solve for this. Okay, 90%, 1800, okay, another 0, 1, 2, 3, okay, 1, 2, 180. It is 180. It is 180 plus, to multiply this, 8 9 is 72. 72 plus 7, 9, 79. 15.92 plus 2 4s are, okay, 4. Now you add 180, 15.92 and then 4.04, so it comes to 9.99 and 9, 199.9, 1.99.96, so that is very close to 200. See, the answers are very close, so tumba approximate ಮಾಡಕ್ಕೆ ಹೇಳಕ್ಕಾಗಲ್ಲ 90% ಇದೆ 200 ಅಂತ ಮಾರ್ಕ್ ಮಾಡಬೇಡಿ. The answers are very close to each other, therefore you have to do this method only, and it is also known as average atomic mass. So this is how we calculate the atomic mass of an element if it is having isotopes. So answer will be this one, 200 AME. The ratio of mass of 1 mole and 10 to the power of 23 atoms. So 1 mole means it is 6 into 10 to the power of 23 divided by 10 to the power of 23 means divide this by 20 to the power 23, so that comes to 6. So ratio of 1 mole and 10 to the power of 23 atoms will be 6. See, here it is Avogadro number divided by 10 to the power of 23. This is the ratio that is asked in the so the answer is very close to the answer A, 6.02. So answer is A. This is the answer. Mass of an atom of carbon is, see, mass 1 mole of carbon weighs 12 gram, that means 6.02 10 to the power of 23 atoms weigh 12 gram. So 1 atom of carbon means it is 12 divided by 6 in the approximate mark 10 to the power of 23. So it comes to nearly 2 into 10 to the power of minus 23. So ಅದಕ್ಕೆ ಕ್ಲೋಸ್ ಆಗಿರೋ ವ್ಯಾಲ್ಯೂ ಯಾವುದಿದೆಯೋ ಅದನ್ನ ಚೂಸ್ ಮಾಡ್ಕೊ. ಸೊ ಆನ್ಸರ್ ಈಸ್ ಸಿ. ಇಲ್ಲಿ 10 to the power of plus 23 ಇದೆ, ಸೊ ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡಿ. A sample of calcium carbonate contains 40% calcium, 12% carbon, 48% oxygen. Therefore, mass of calcium in 5 gram of CaCO3. See, it is nothing but almost the atomic masses of calcium, atomic mass of carbon, atomic mass of oxygen. So it will be calcium carbonate molar mass calculate ಮಾಡೋಣ. So molar mass of calcium carbonate will be 40 plus 12 plus 48, that comes to 100. So 100 gram of calcium carbonate contains 40% of calcium, 12% of carbon, 48% oxygen. That is correct. See, 100 gram of calcium carbonate contains 40 gram calcium. Therefore 5 gram of calcium carbonate contains how many grams? 6 gram of calcium. ಮತ್ತೆ ಅದೇ ತರ ರೇಷಿಯೋ ಮಾಡ್ಕೊಳ್ಳಿ. 100 divided by 5 is 40 divided by x. Therefore x will be equal to 40 into 5 divided by 100. So we solve for this. X equals 2. I have that answer. Okay, 2 gram. So 2 gram of calcium carbonate will have 5 gram of calcium in it. So that will be the answer. The total number of atoms present in 0.1 mole of sucrose. See, in this chapter you find many this type of problems. They are not very big problems. They do not involve lengthy steps, very simple steps, but variety of problems you come across. ಇಲ್ಲಿ atoms ಅಂತ ಕೊಟ್ಟಿದೆ, ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ. 0.1 mole of sucrose. See, 1 molecule of sucrose contains how many atoms? 12 plus 22 plus 11. So it will be 5. Okay. Is that correct? 12 plus 22 plus 11, 2, 2, 1. 5. Okay, 45 atoms are there, 1 molecule. So 1 mole will be containing Avogadro number of molecules, no doubt, 6.0 10 to the power of 23 molecules of sucrose, but atoms anta helidre 6.02 10 to the power of 23 multiplied by 45, because every molecule contains so many atoms. Now it is 0.1 mole. That means you have to multiply this whole thing by 0.1. 10 to the power of 23, 0.100 10 to the power of minus 1. This is 45 times. So this will be 10 to the power of 22. Some answer in 10 to the power of 22. We find 10 to the power of 22 will ಕಾಣಿಸ್ತಾ ಇದೆ. If we multiply, what we get? 6. 5. So I take it as 6. When it becomes 27, okay. 270 into 10 to the power of 22. So agar idu 2.70 into 10 to the power of 22. That will be the answer. 24. So powers conversion ella serisi we get the answer as this, not the A. This is the answer. After multiplying 6 and 45, you get this as the answer. So many atoms are there in 0.1 mole of sucrose. Similarly, they may give different compounds. Which one of the following has a maximum number of molecules? See, 1 mole of H2O will have 6.02 10 to the power of 23 molecules. 32 gram of carbon monoxide. See, carbon monoxide 1 mole means it will be 12 plus 16, totally 28 gram. So 28 gram is 1 mole. 32 gram will be 1 over 28, 32 times. That means it will be 8 by 7. 8 by 7 means it will be just maybe around 1.05 mole. So this is 1.05 mole of carbon monoxide. That means it will have more molecules than H2O. 2.27. See, 22.7 liter will have 1 mole of nitrogen. 2.27 will have 0.1 mole of nitrogen gas. So option C is 0.1 mole, converting everything into mole. So molecules bad answer. 22 gram of CO2. 44 grams CO2 is 1 mole. So 22 grams CO2 will be half of that. So half of that means 0.5. So answer for this question, maximum number ಅಂದರೆ ಯಾವುದಕ್ಕೆ ನಂಬರ್ ಆಫ್ ಮೋಲ್ ಜಾಸ್ತಿ ಇದೆಯೋ that is B, 32 gram of carbon monoxide, it is 1.05 mole. So if you convert all this into mole, you will understand which contains maximum amount. Amount ಯಾವ್ದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ, mole ಯಾವ್ದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ, that will be having more number of molecules, that is B, carbon monoxide. Only thing is you have to convert the mass and volume into mole. 2.27 liter of nitrogen into a test TP has same number of molecules as in. So we shall consider standard volume as 22.7 liter. That will be having 1 mole. But if you say 2.27 liter, that will be 0.1 mole. So 0.1 mole of nitrogen is given. So 8.8 gram of CO2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. See, 44 gram is 1 mole. 8.8 means it will be 8.8 divided by 44. So it is 0.8 divided by 4, that comes to 0.2. So first one is 0.2 mole. For ammonia, 1 mole is 17 gram. See, for ammonia 1 mole is 17 gram. 0.1 mole means it is 1.7 gram. I think B should be the correct answer. This should be the answer, because this is 0.2 mole. 64 gram of SO2, I think it is about 1 mole, because it is 32, sulfur 32 and 2 oxygen atoms 32, again it is 64, it is 1 mole. Here 16 gram is 1 mole. 3.2 gram means it will be 3.2 over 16, it comes to 0.2 once again. So this is 0.2 mole. Actually A and D have same number of molecules, but here it is 2.27 liter of nitrogen. Answer will be 1.7 gram of ammonia. They have 0.1 mole amount. So they will be having same number of molecules. The number of molecules present in 1 drop of water weighing. Okay. See, 18 gram of water is 1 mole, and that will be containing 6.02 10 to the power of 23 molecules. Now 0.018 means how many molecules. You take it as x, so ಇದನ್ನು ಫ್ರಾಕ್ಷನ್ ಥರ ಮಾಡ್ಕೊಳ್ಳಿ, ಸಾಲ್ವ್ ಫಾರ್ x. So x is 6.02 10 to the power of 23. So 18 to 10 to the power of minus 3. You can see here. Then it is 18. So if you solve, you are going to get 6.02 10 to the power of 20. This will be the answer. Plus 23 minus 3 10 to the power of 20. So it is 6.02 10 to the power of 20. So ಕಡಿಮೆ ಅಂತೂ ಇರಬೇಕು, ಜಾಸ್ತಿ ಆಗಲ್ಲ, ಈಕ್ವಲ್ ಆಗಲ್ಲ. It is 6.02 10 to the power of 20 molecules are present in 1 drop of water, and answer is C. The number of atoms present in 90% pure silver wire weighing 10 gram. So you are given 10 gram of silver wire and it is 90% pure, means 90% of 10 gram is silver. So mass of silver in the given wire is 90% of 10 grams. So that will be 9 gram. So 9 gram is there. So molar mass of silver usually ಕೊಟ್ಟಿರ್ತಾರೆ, it is 108. 108 is 1 mole, or that is 6.02 10 to the power of 23 atoms. So 9 gram means it will be 6.02 10 to the power of 23 divided by 108 times 9. Now you can see you can solve it very easily. So it will be very close to 5. So 5 into 10 to the power of 0.5 into 10 to the power of 23 ಬರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಕ್ಲೋಸ್ ಆಗಿರೋ ಆನ್ಸರ್ ಯಾವುದು ಅಂತ ಚೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ದಿಸ್ ಒನ್ ಶಿಫ್ಟ್ ಮಾಡಿ 5.57 10 to the power of 22. So this should be the answer. So only thing is you have to calculate the mass of silver in the given vial. So that is 90% of 10 gram ಅಂದರೆ 9 gram ಆಯಿತು. Silver molar mass is 108. So from that you have to calculate the number of atoms of silver in 9 gram. The number of atoms in 52 U of helium. See, 1 AMU atomic mass unit or 1 unified mass, it is the mass of one atom. Helium has 4 U. One atom of helium weighs 4 unified mass. That is 1 AMU is 1/12 the mass of one atom of C12 isotope. Now 52 U means how many atoms? So X number of atoms. See, 4U is one atom. So take this as a ratio, then it will be X is equal to 52 by 4. It will be 13. So it contains 13 atoms. So mass of 13 atoms of helium will be 52. A hydrocarbon contains 92.5% carbon and rest is hydrogen. What is the empirical formula? Now hydrocarbon means it is only carbon and hydrogen, carbon, hydrogen. This is 92.5. So 100 minus 92.5, how to calculate how much it comes to? It is 7.5% hydrogen. Now divide that by the corresponding atomic masses. So it is the familiar formula. So this also comes to 7.5 almost. 7.5. Now divide them by the least number, 1:1 ratio. So the empirical formula will be C1H1. The simplest formula or empirical formula of the compound will be C1H1. They are present in the ratio 1:1. So empirical formula will be CH. That will be the answer. See, the compound molecular formula we cannot predict. It may be like C2H2 or it may be like C6H6. So we cannot predict that, but you can predict the empirical formula, CH. 1 mole of methane is burnt in 10 gram of O2. How many grams of methane is left over according to the reaction? Okay, the reaction is methane plus 2O2. It is combining. 16 gram of methane requires 2 into 32 gram of O2. But we are not providing so many grams of oxygen. Therefore, oxygen O2 will act as the limiting reagent. So it is the problem based on limiting reagent which is completely consumed in this reaction, and that determines the amount of the product formed in this reaction. It will be consumed completely. How many grams of, it is 10 gram it is given. So 10 gram of oxygen burns with how many grams of methane? So it is once again make it as a fraction as such, 2 into 32 divided by 10. So X will be 16 to 10 divided by 2 times 32. Now wherever it is possible to solve, we can solve this. So it will be 2.5 gram. 2.5 gram will be, is that correct? Okay, do we find the answer? That is the doubt. It is 10 gram of O2. 2.5 gram will be burnt. So how much will be left over? 16 minus 2.5. So that should be the answer. So it is nearly 13.5. So I don't find any answer here. So maybe the answers are wrong. 16 gram of methane requires 2 into 32 gram of oxygen. X gram requires 10 gram of X gram. 10 gram is given. Okay. 16 gram is given. 10 gram of oxygen gas. So how much will be burnt? That will be, there is some problem here. 5 by 2, 2.5 gram is burnt. So how much left over? It is 13.5. 13.5 nowhere is the answer. So I'll consider it as a grace pass. The answer should be, so we will change Madana. Let us take it as 13.5. That will be the answer. So leftover grams of methane, because limiting reagent is O2, methane will not be completely reacted as per this equation. Carbon monoxide alla barutalla anta you think already, the equation is given. So it will be 13.5. 4 liter of water is added to 2 liter of 6 molar HCl. So you have to use the formula M1 V1 equals M2 V2. So one of them is before, say before mixing, and say this is after mixing with water. So M1 is 6 into 2 liter is equal to M2. Now the total volume you have to consider 4 plus 2, that is 6 liter. So M2 will be 6 into 2 divided by 6, so that cancels, will be 2 molar. So resulting solution will have the molarity 2 molar. See, for dilution type of problems, this is called dilution, adding solvent to the given solution. You can use this formula M1 V1 equals M2 V2. The molarity of the solution obtained by mixing 800 ml of 0.5 molar HCl, 200 molar of 1 molar HCl will be. See, this is another type of problem where the dilution involves 2 solutions of different concentrations. Then you have to use this M1 V1 plus M2 V2 will be equal to M3 V3. Then it will be 800 to 0.5 plus 200 to 1, and M3 total volume you have to consider 800 plus 200 ml. Total volume of the solution after mixing will be 1 liter. This will be how much? 400 plus 200 plus M3 times 600, 1000. 3 times 1000. Therefore M3 will be 600 divided by 1000. So it will be 6 by 10 means it will be 3 by 5. 3 by 5 will be 0.6. Okay, it is 0.6. 0.6 molar is the answer. So when you are mixing only water, then you have to use the previous type of formula M1 V1 equals M2 V2. See, only water is added here, not another HCl solution. But when another HCl solution is added, 2 solutions of the same substance of different concentrations, then you have to use this formula M1 V1 plus M2 V2. So ಇನ್ನೂ ಏನಾದ್ರು ಕೊಟ್ಟಿದ್ರೆ add ಮಾಡ್ಕೊಂಡು ಹೋಗಿ gives the final solution. So answer for this question will be 0.6 molar. 6.02 10 to the power of 20 molecules of urea are present in 100 ml of the solution, so what is the concentration of the solution? Say 6.02 10 to the power of 23. That means 1 mole of urea is present in 1 liter, 1000 ml of the solution. Then we say it is 1 molar solution. If 6.02 10 to the power of 20 molecules are dissolved, what is the molarity that you have to calculate? So 6.02 10 to the power of 20 is how many mole? So how many mole you have to calculate? So take it as x, then it will be x equals 6.02 10 to the power of 23 divided by 6.02 10 to the power of 20. Is that correct? Okay, cross multiply 20 divided by 20. So that is 10 to the power of minus 3. So it is 10 to the power of minus 3 mole. Now apply the formula of molarity. 10 to the power of minus 3 divided by 100, that is N over V into 1000. So that you have to apply the formula. Then wherever it gets cancelled, cancel it out. It is 10 to the power of minus 2 is the molarity. 10 to the power of minus 2 means 0.01 mole. 0.01 mole. See, this is the molarity of the solution. See, instead of giving the number of moles of solute, they have given the number of molecules that should be converted into number of moles. Number of moles is 10 to the power of minus 3 mole. So you apply the formula of molarity N over V into 1000, where N is the number of moles of solute. Then you get the answer as 0.01 molar. One of the following natural extracts which is used to treat AIDS. See, this is from the introduction part of this chapter. Cisplatin is actually not natural at all. So you can rule out that answer. It is a man-made compound, it is synthetic. Taxol is used to treat cancer. Cisplatin and also, see, both these are anti-cancer drugs, cisplatin and Taxol. Among that, Taxol is naturally occurring. It is obtained from the bark of a tree called Taxus brevifolia. Cisplatin is a complex compound obtained from platinum. AZT is also known as azidothiamidine. See, azidothiamidine is a natural extract which is found to be working against the AIDS. Whereas CFCs are refrigerant, they are also man-made compounds, they are not the natural compounds. Therefore, you can guess the answer as AZT. It is a drug, natural drug used to treat AIDS. Okay students, that's all. I have tried to give as many questions as possible from all the topics that are discussed in this chapter. Some basics of organic chemistry, every part of the chapter I have tried to touch. Okay, thank you very much and all the best.